Hello, Mario Warriors. Welcome aboard. Hi, Sherlock Holmes. Hello, Shabu. Hi, Adi. Hello, Arvind. Hi, Shita. Hello, Kuna. Hello, Santosh. Hello, Nagarjuna. Hello, Suman. Welcome, guys. Welcome. This is Captain Shreyas here, welcoming you all on the JEE English channel. And like you all aware, because the JEE exams around the corner, so we have devised the fast track series for you guys to prepare the most important high weightage topics, both of 12th as well as 11th standard. Also, obviously, it will help you in your boards as well and any other competitive exams like EMSAT, BITSAT. So this is a series, the series for all the JEE, BITSAT, EMSAT and any such competitive exam aspirant. And in the previous session, I had premiered the shortcuts, the formulas, the mind maps, everything for ray optics and optical instruments with prisms, everything. I hope you have seen it. And if you have seen it, let me know in the chat box saying that, yes, sir, I have seen, or just say the word seen, so that I know you guys have seen that lecture and come. And in case some of you do not know where to find it, let me just show that to you as well. As you are watching this lecture, let me show this to you. I hope, yes, seen, very good, very good. So you can go to videos tab, you can see this ray optics in 35 minutes, guys. I have taken a lot of efforts to make this lecture, so 35 minutes. So please watch that in case you have not seen it, okay? And that will help you obviously for this session. I have also shared the PDF of those notes as well, okay? So make sure you have checked through the notes. It will be very useful. You can save it, you can add pointers, you can add concepts, you can do whatever you want in that notes. That is like, going to save you a lot of time. Thank you for smashing the like button, guys. Can we see this session for NIT? Yes, definitely. Yeah, in yesterday's video, you saw two different avatars, one the previous one and one the new one. Yes, that's true. One part I had shot it long time back. Okay, great. So thank you for smashing the like button and also hitting the subscribe button, guys. Here is our first question up on your screen. An object of mass m is moving with some speed u. You can see over here. There is another object on which there is a mirror which is attached, and the mass of the mirror stand and the system is m. So this guy's mass is m, this guy's mass is n. This is at rest. This mass hits this mirror mass system. Then the question is, what is the velocity of the image before and after the collision? All right. Yes, I know 27 days, but don't look at the days or don't keep countdowns. Just focus on studies. Just keep solving problems. If you focus on the date, then you will not do anything. All right. So let's see. Hello Suchimama. Hello Srinu. So in order to solve this question, I feel you should use the knowledge of collisions as well. The first situation, I'll use the before situation. In the before situation, what is going to happen is this object is moving with speed u. This mirror is basically going to be at rest. Hence, the image which is there, the image is going to move this side with the speed of u. So object goes this way, so hence the image is just going to go towards the left side with the same speed. So minus u should be there. So option D gets eliminated and option A also gets eliminated. For the situation afterwards, what happens afterwards is that this guy's mass and this guy's mass is same. What happens in an elastic collision when masses are same? The speeds get exchanged. So the speeds will get exchanged. All right. So observe. Just one. That's the reason why I'm conducting these classes. You see how I'm thinking. There is no one line solution to tell that, okay, this is how you solve problems. That's why you have problem solving sessions, or else you can just download the solutions. There is no point. So during elastic collisions of same masses, of same kind of masses, what happens is that the speeds get exchanged. So the speeds definitely get exchanged. So this object which is there, that will come to rest. You have the mirror, that mirror will start moving with speed u. Naturally, what will be the speed of the image, guys? I think I have told you how to solve these kind of questions. The velocity of the image formula, guys, come on, it is 2vm minus vo and all that I have given you. So if the mirror moves with x meters per second, the image will move with 2x meters per second. So hence the image will have 2u speed. So where is 2u, guys? Exactly, this is over here, option C, like you can check on your screens. So minus u and plus 2u, plus because it's going that side, minus because it was going towards the left side. That's how you get the answer. Moving on to the next question. Here it comes. Two mirrors are inclined at an angle of 45 degrees. An object is placed symmetrically. How many number of images are formed? How many number of images are formed? Come on, my warriors. What should be the answer? What should be the answer for this? Come on, think about it. Think about it. What formula are you going to use for inclined mirrors? All right. So first of all, let me make you visualize this via diagram. This is 45 degrees and you have an object over here. We all know that images will be formed in a kind of a circle over here. So these are basically the images. Whenever you have to solve these kind of problems where inclined mirrors are given and find the number of images, always divide 360 degrees with the angle mentioned. Here it is 45 degrees. So how much will it be, guys? It's just going to be 8, right? Now check if it is even or if it is odd. If this is even, like you can see, the total number of images will be that number minus 1. So in this case, it is going to be 7. Very good, Arvind, Sri Priya, excelente. If this was odd by chance this was odd, then don't do minus 1. This minus 1 comes only because it is even. If it was by chance, if it was odd, then that number is as it is. So always try to keep it odd. That's the logic in these kind of questions. So option D is the correct answer. Very good, guys. Excellent. Moving on to the next question. For a concave mirror, I hope you guys are enjoying a lot because lots and lots of questions for your practice for JEE is going to come. And in this short and sweet session, guys, you will, solve those problems which otherwise you would have taken a lot of time, or you did not have motivation, or you felt that you are getting distracted. Just focus and attend the class. In this short duration, trust me, you will solve so many problems. Otherwise, you would have just wasted this 1.5 hours. For a concave mirror of focal length 20 centimeters, if the object is at 30 centimeters from the pole, then the nature of the image and its magnification will be. Okay, so nurture or zero to hero for NIT 2023. I think it should be a combination of both depending on how difficult or how long any particular topic is. If it's easy, if you can do it in zero to hero, then go with zero to hero. Else, for that particular chapter or subtopic, use nurture or pathfinder. Okay, so what we can do over here, because the focal length is given and it is a concave mirror. Remember, for a concave mirror, the focal point is this side and the object is given to be over here. So obviously this is negative side. So object distance is minus 30, focal length is minus 20. So I'm just going to use 1 by V plus 1 by U is equal to 1 by F. Correct? So let's try to see what happens. So 1 by V plus 1 by U, U is nothing but minus 30 is equal to 1 by F, which is nothing but minus 20. So 1 by V is equal to, take this guy on the other side, it will become 30 minus 1 by 20. Take LCM, 30 and 20, the LCM is 60. 30 goes with 60 2 times, 20 goes with 60 3 times. So this is going to be minus 1 by 60. Flip it. So V goes on the top. V goes on the top. So it will just become minus 60 centimeters. So this negative sign implies that the image is also formed over here. So therefore the image is going to be real. This is the real side. If it forms behind, then it is virtual. Now the last thing that you need to do is, I think, magnification. Magnification is nothing but minus V by U. So it will be minus, image distance is minus 60, object distance is minus 30. So minus minus cancel, 60 by 30 is nothing but 2. So this negative sign implies that it is inverted, and this 2 signifies that it is enlarged. Definitely it is enlarged, but it is inverted. So where is such an option? Right over there, real and minus 2, option A. No, it is not C, guys. It is minus 2. I think some of you missed that negative sign. That's why a lot of people are going to lose marks, and that's why this can come in JEE mains. And they play along with you. So all these things happen, guys. So learn from the mistakes, because in the exam, I don't want you to blank out. I don't want you to get confused. So you keep your tricks, you keep your formula book, revise, solve problems as much as you can. Do not get confused with the signs and formulas. Moving on to one more question like this. Object is at 20 centimeters from a convex mirror. Focal length 10. The image formed by the mirror is. So this is your redemption question, guys. If you made some mistakes in the previous question, make sure you do not repeat any kind of mistakes in this. It's a convex mirror. So I'm just going to show a convex mirror. Focal point is going to be here. Okay, this is the positive side, this is the negative side, this is where you're going to keep the object. So according to the question, the object is placed at a distance of -20, the focal length is going to be 10. So if I use 1 by v plus 1 by u is equal to 1 by f, 1 by v I don't know, u is nothing but -20 is equal to 1 by 10. Taking it on the other side, 1 by v is equal to 1 by 10, minus becomes plus, so 1 by 20. LCM is just going to be 20. 10 goes with 22 times, 20 goes with 21 time. So 2 plus 1 is nothing but 3 by 20. Flip it, so you are going to get v is equal to 20 by 3. Because it is positive, that means the image is formed there. So it is definitely going to be virtual image. It's going to form on that side, which is behind the mirror, which is virtual image. So virtual and 20 by 3 centimeters from the mirror, which is option C. Very nice, Dinesh. Excellente. Okay. Why real, Sirmura? See, when you have a mirror, whenever it is behind, understand this. So whenever you are behind a mirror, it is basically virtual because you are seeing it inside the mirror. Like when you see your face, it is formed, the image is formed behind the mirror. And this in front of the mirror becomes the real side. So that is why this is virtual. In the previous problem, you can see it is formed in the front. So that is the reason why it is real. If it was formed behind, then it will be a virtual image. I hope this is clear, bacha log. Okay, moving on to another question coming up on your screen. Why you are taking negative values, Jaswant? I mean, where am I taking negative values? For object distance, you mean? For object distance, because object is placed 20 centimeter from the convex mirror. This is the convex mirror, object is placed here, this is the negative side, this is the positive side. Because the rays of the light will come from the object. I hope you remember the sign convention. In case you have forgotten, please watch the replay again, okay, of the mind maps and the formula session. But simple terms, the light rays will go that side. So whichever side they go, that side becomes positive, the other side becomes opposite direction, becomes negative. Okay? Yes, these kind of questions have come in JEE. So if you open up previous year papers, even 2020, 2021, 2022, they have asked these kind of questions in the JEE examination. Here comes another one. A ray of light strikes a glass plate at an angle of 60 degrees with the vertical. If the reflected and the refracted rays are perpendicular to each other, then the refractive index of glass is. Again, a very common concept based question. So I'll just show you the diagram. It will be very, very clear. So a ray of light strikes a glass plate and a part of it gets reflected and a part of it gets refracted. So this is reflected light. Okay, this is your incident light and this is your refracted light. As per the given question, you know, the reflected and the refracted rays are perpendicular to each other, and this can only happen in one given situation. If you remember Brewster's law, I know this is not basically there in ray optics, but you can basically import that formula. You can use that formula here. Brewster's law says that if you have unpolarized light and this light becomes polarized after reflection, then the tan of that angle of incidence will be equal to mu, and the reflected and the refracted rays are perpendicular. That was Brewster's law principle. So tan of what is the angle, my dear students? I think it is given at 60 degrees. So tan 60 is mu. So mu will be nothing but √3. Nothing but √3. So where do you have √3, guys? Option D. Exactly. You can see that option D. No, Archit, it is not A. No, Bhagya, it's not C. Yes, Hari Prasad, it is D. Very good. SS Naren, Karthik. No, Shabu, it was not A. Yes, Mugesh, very good. Tan of I is equal to refractive index. It should just click at that moment that it is not even, so much got to do with ray optics. You can definitely use some other chapter's concept. And this happens many times. It feels like the question is from one chapter, but it ends up being from other chapter. You can use other chapters. There is no hard and fast rule. Oh no, sir, I thought ray optics, ray is there. Nothing like that. You can use anything that you want to solve the question. Length of the vertical pole is 30 centimeters and it is 6 centimeters below the surface of the lake of water. to an underwater fish just below the water surface, the tip of the pole appears to be. Hello Karthik, yes bacha, long time. Now what you can do is just draw the diagram, things will be very clear. So this is basically the water, this is basically the water. So the fish is somewhere over here, the fish is somewhere over here. The pole which is there, it's long enough like this, okay, 6 centimeters is below the surface of that lake, and the remaining part will be above. So out of 36, if it is below, so obviously this is 24 centimeters. The question is, where is the tip of that pole? So you can see this is that particular tip of that pole. That tip becomes my object. The tip becomes my object. And if this fish now becomes the observer, the fish is now the observer, when you look at a rarer medium, that point appears really far away. That point appears, where does it appear? It appears far away. So the image will be formed over here. The image will be formed over here, and this then will be your apparent height. This will be your apparent height, and this apparent height is actual height multiplied by mu, because you are in denser medium. If you are outside here and you look at an object here, then it will appear closer, then you will divide it by mu. So when you are in rare medium looking at something dense, it will appear to be shallower. If you are in the dense medium looking at a rare medium, like in this case, it will appear farther. Is that making sense, my dear students? Okay, so what is the actual height? It is 24. What is the value of mu? I think it's given over here, 4 by 3. So 3 goes with 24 8 times into 4. So this is basically 32 centimeters. Where do I have 32 centimeters? Yes, option C is the correct answer. Very good, Arvind. Very good, SS Naren. Kudos, guys. First Arvind said B, then went to C. No, Archit, it's not B. It is basically going to be C. Can we use Snell's law? Srimura, if you use Snell's law, it will be very complicated, because there are many rays which are going to come out of that object. There will be one ray coming like this, another ray coming like this. This will refract, this will refract. You have to extend it backwards, and that's how the image will be formed. So using Snell's law, you will get it, but it will be the derivation then. Basically, you are deriving this formula. So why do you want to do that? Because you have to just apply it in the JEE exam, right? Making sense? Okay. So Karthik and others who are getting less marks, I feel you should focus on those topics which are giving you less marks. Just giving mock tests is of no use. If you are getting less marks, then you'll just probably end up wasting more time. Instead, in that mock test time, you can give some part test or just the chapter specific test like we are doing over here. Hari, you are late, but you can watch the remaining part later on. Just concentrate on the live. Can we solve from the fish view and use laws of principle of reversibility? Hari Prasad, from the fish view, you are seeing it exactly from the fish view only. You are the observer here, and you are seeing where that object will be formed over here. The object's image will be formed over here. If you stand outside, then this point will appear closer. That will not give you the answer. That will give you something else only. So understand that when you stand outside, it will appear closer. When you stand inside, then it will appear farther. Completely different thing. Okay. Moving on. So for the previous problem, can you solve using Snell's law? Definitely, bacha. This previous problem, you can use Snell's law as well. Definitely. You can assume this is I, this is also going to be I, and then this is going to be R, and this is perpendicular. This is 90 minus I, and then this is again I. So again, this is 90 minus I, and then you can use Snell's law and then solve it. Yes, definitely you can solve it using Snell's law. Definitely. Okay, weightage of the chapter, at least 2 questions you can expect, 1 to 2 questions, very, very common. 1 to guarantee, 2 is very likely, 3 is rare. That's what I would say. Hello Sanjit, Krishna. Okay, so Dharun, I think I just gave you an example where you can use Snell's law, where the angles are specifically given, or maybe angle of incidence is given, or those kind of problems where there is a sphere and then there is a ray which is falling onto it, it gets refracted like this and then it comes out. So in these kind of questions, you will generally use Snell's law. Or just one single surface is there and rays are given and you have to find the angle of refraction or some condition is given. Okay, so that's where you are going to use Snell's law. I hope that is clear, bacha. Okay. So Kuna, you have to attend mock test from the crash course. Link is there in the description box. Chapter wise assignments, which you can use it like mock test also or practice. and then you have part test and then full syllabus test. So link is there in the description box. Make use of it completely. A microscope is focused on a needle lying in the empty tank. Now the tank is filled up to benzene height of 120 meters. You have to shift the microscope. So question is, what is the refractive index of benzene? Yes. So when do you use Brewster's law? One, when you have basically polarized light being made out of reflection, number one case. From unpolarized light, you are getting polarized light by reflection. Number two, you see incident is such that the reflected and the refracted are perpendicular. That's when you can use Brewster's law. Only two situations. Okay, now for this problem, the microscope is focused on the needle, okay, maybe somewhere over here lying in an empty tank. So this is an empty tank and this is our microscope, maybe over here. Now the moment you fill some liquid over here, what happens is that, okay, this object which was here, the image will be formed over here. So definitely there is going to be some kind of a shift in that image, and that shift happens by this formula, the thickness into 1 minus 1 by mu. This is the formula for the shift when you use a glass slab or a container which has some liquid. Everything below shifts by thickness, or this thickness, into 1 minus 1 by refractive index. If you are wondering what thickness is, this is basically the thickness. So obviously you will have to even shift this microscope by the same amount to maintain the focus, because the object came up, the object's image came up. You will have to shift the microscope slightly up so that you can still keep it focused. So that's all, guys. So let's try to solve the question now. So the shift is given to be 40 millimeters. The original height of the benzene is given to be 120 into 1 minus 1 by mu. So 40 by 120 is 1 by 3, is 1 minus 1 by mu. So 1 by mu I can take it there. So it will become 1 minus 1 by 3, which is basically 2 by 3. Flip it, you will see mu is equal to 3 by 2. So 3 by 2 is 1.5, which is option A. Yep, it is 1.5, guys. Okay, how to find angle in case of prism problems? Mazib, like I said before, first of all, you need to check out the session which I have conducted before. Okay, this was your, mind maps and formula session. Here I have explained even prisms in 35 minutes. Okay, so watch that. There you will get some formulas. And now I'll be doing some prism problems. There you'll get some more ideas. See me solve problems, number 2. Number 3, if you're still not satisfied, watch my Zero to Hero playlist, or just specifically use the playlist of prisms in the Pathfinder playlist. You can see sections in the playlist, 11th, 12th and all that. So use the 12th standard physics playlist. You can just see one complete lecture on prisms if you are getting demotivated by prism problems alone. Okay, so we are going to come to prism problems as well in some time. A fish looks up through the water, sees the outside world contained in a circular horizon. The refractive index of water is this much. The fish is 12 centimeters below the surface. The radius of the circle in centimeters is. Okay, Manda, I have already explained what is the weightage. Probably you can ask on the chats to others, or maybe others can help. Those of you who are attentive know what is the weightage of the chapter. So here it is. The fish is inside. This is where the fish is. This is where the fish is. And how deep is it inside? It is 12 centimeters below. So this is 12 centimeters below. There will be certain rays from the outside world which would be entering the fish. But after a point, you will see that total internal reflection will occur. And the rays from outside world cannot enter inside of it. As you increase the angle of incidence, as you take more and more rays which are away from this point, you will see as the angle incidence, there are higher chances of internal reflection. So there is total internal reflection. So definitely there is total internal reflection which is happening over here. So the last ray which will enter my eye, is going to be this one probably. And you can see that it forms a beautiful right angle triangle, and this point is there everywhere on the surface. In fact, it becomes like a circular patch on the water surface. it becomes like a circular patch on the water surface. In that patch, the rays from outside are definitely entering in, but after that circular patch, what is happening? The rays are just getting internally reflected. The rays are just getting internally reflected. I hope this is very, very clear, guys. Only inside this patch the rays are entering in. So the question is, what is the radius of such a circle? What is the radius of such a circle? I just know one more thing. If I draw perpendicular here, this is the critical angle, and so is this the critical angle, because these are two parallel lines. So this is also critical angle, and we all know sine of that critical angle is 1 by refractive index. That's the formula. So mu is given to be 4 by 3. So basically sine of IC is 3 by 4. Now how do I find radius? I know from here that tan of IC is nothing but opposite side by adjacent side, which is 12. But I do not know tan, I just know sine. I can just quickly draw a simple triangle to help me out. This is I. Sine is opposite side by hypotenuse. Naturally, this side will be root of 4 square minus 3 square. So 16 minus 9, which is nothing but root of 7. So tan of I will be opposite by adjacent. That's it, is going to be r by 12. So r will be 12 3s are 36, and I have root 7. So 36 root 7, guys. Just check this out. So there is no need to by heart any formula. Please don't sit and by heart formulas. Just solve it logically. You should know the logic for these kind of questions. This is a very, again, important question. All these models of question which I am taking today are very, very important, highly probable, very, very, a good chance that these kind of models will get repeated in many of the shifts, because I've analyzed all the papers in the past few years. All right, moving on to another question. This is a beautiful question, guys, coming up on your screen. Diameter of a plano-convex lens is this much. Thickness is this much. What is the speed? If the speed of light is this much, focal length. Now, if I remember correctly, to find the focal length, what I need is mu minus 1 formula, 1 by r1 minus 1 by r2. Now, I don't know the refractive index, nor do I know the radius as of now. So let's find everything one by one. Okay, let's start with refractive index. I know the speed of the light is given. So what I can do is speed of light in the medium is speed of light upon mu, correct? So basically mu will be 3 into 10 to the power 8. Speed of light in the medium is 2 into 10 to the power 8. Bring mu on the top, bring cm below. So this just becomes 3 by 2. So if mu is 3 by 2, I can just put that over here. So this will just become 3 by 2 minus 1. So this will just become half. Now what happens over here? That is something we need to see. Now how do I find R1, R2? I think I'll start drawing a simple diagram. It's a plano-convex lens. So I think I should draw a straight line here, and this is the curved surface out of it. What is given? Understand the diameter of the plano-convex lens. Meaning, understand this. If this is the plano-convex lens, it looks something like this. This is what is given. And that is 6 centimeter. So obviously the radius will be 6 by 2, 6 centimeters by 2, which is 3 centimeters. Cool? Okay. What I need is the radius of curvature. That's a completely different thing. So if I think of a big circle which this arc is a part of, the center of curvature will be here. This would be the radius. Just visualize this and try to also imagine a big circle right over here. So this plano-convex lens is a part of a big sphere. So now you can see this is the radius, and I know that over here, if I draw this horizontal line, this much is basically 3 centimeters. This much is basically again 3 centimeters. And what is also given to you is this length. This length is 3 millimeters. The thickness at the center is 3 millimeters or 0.3 centimeters. Now, how do I find R from this? One option which I've seen many people do is using Pythagoras and then approximations. Okay, just check this. Okay, one option is using Pythagoras. Okay, somebody is saying for the previous one 36 by root 7. Oh yes, thank you bacha. Yeah, this should have been 36 by root 7. Thank you very much. 36 by root 7. And let's just see. Oh yeah, I think the option marked over here was also wrong. Okay, thank you very much. So it should be 36 by root 7, guys. So this is the correct answer. Thank you very much. Who was it? Sanjeet Krishna. Very good. You guys are paying attention. Good. All right. Moving on. Now, what do I do? For getting the radius? I will not use Pythagoras and approximations. That will create unnecessary problems. Instead, I will use a theorem. And you know what that theorem is? The theorem is simple, guys. So whenever you have a circle, okay, whenever you have a circle and a chord and a diameter, this side into this side into this side is this side into this side. Very important property. If you have a chord perpendicular to the diameter, then the sections of the chord, if you take the product, is also the product of the sections of the diameter. So this into this is this into this. So now clearly see, these two crosses are right over here. This is that crosses. So each of them is 3 centimeters, like you can see. So 3 into 3 is equal to this much into this much. This much is basically 0.3. This whole thing, what will that be? Obviously it will be 2r, which is the diameter minus this much. So it will be 2r minus 0.3. So 2r minus 0.3, of course. Now 3 divided by 0.3, that's going to be 10, is equal to 2r minus 0.3. So 2r is going to be 30 plus 0.3. So r will be nothing but 15 plus 0.15, which I can approximately take it as 15 centimeters. That 0.15 is negligible. So here in the R1, R2, radius of curvature of the first surface and the second surface, the first surface, I'm just going to put the radius as 15. The other surface, because it is plane, it's going to be infinity. This is because it is a plane. For a plane surface, it is infinite radius of curvature. So that's it, my dear students. 1 by infinity is 0. 1 by a very large number is 0. 1 by 15 will come over here. So that will make it 1 by 30. So F will be, flip it, because this was 1 by F. F will be 30 centimeters. 30 centimeters. That's it. That's the answer. Okay. So, thank you, Prasad. Atarsh, the last part I'll explain you. Bacha, observe. Whenever you have a circle, okay, this is a geometrical property. What is that geometrical property? Observe this. If you have a diameter and you have a chord, both are perpendicular, then the chord will be divided by the diameter will be divided by the chord. This part multiplied by this part is this part multiplied by this part. If you notice here, this is a circle, this is the diameter, this is the chord, this into this, each is 3 centimeters. So 3 into 3 is equal to, this is the diameter, this part is 0.3 as per the given question, it's 3 millimeters. So this much from here to here will be diameter minus 0.3. That's it. Rest is just simple math. I have just divided this by 2. So 30 by 2 is 15. 0.3 by 2 is 0.15. 0.15 is very small in front of 15, so ignore it. So it's just 15 centimeters. Just use that over here. You can see the first radius I can use it as 15. The second radius I can use it as infinity, because for a flat surface it has very large radius. So whenever you have plano-convex or plano-concave lens, one of the radius will be infinity. So 1 by infinity, 1 by a very large number will be 0. So that's why just ignore this. You just get this 1 by 15. That's all. As it was a very nice question. So plano determines the plane, hence the radius of curvature is infinity. Yes. Yes, Nizaf, you're a little bit late. Watch the replay later on, but continue with the live class. A thin converging lens has the power of this much. When it is put in a liquid, it acts as a diverging lens of focal length this much. The value of the refractive index of the liquid is. These kind of questions, very common. So many times it has come. 1 by focal length, by lens maker formula, is mu of the lens upon mu of the medium minus 1 into 1 by R1 minus 1 by R2. This 1 by F is nothing but power. So you can see power is directly proportional to mu of the lens upon mu of the medium. This is always relative mu minus 1. This will not change just because you change the medium. R1, R2 are physical properties, they won't change. Only this terms might change. So let's try to do it. First time the power is 5 diopters. So 5 diopters. And next time what is the power? Oh, I do not know that. I can find it out because next time it is acting like a diverging lens. The power will be minus, or minus, because the focal length will be negative, because when it diverges, right? So the focal length is going to be negative. So 100 centimeters minus 100 centimeters, but you always put it in meters to express it in diopters. So minus 1 by 1 meter, which is basically minus 1 diopters. So this is the new power. This was the new power after you put it in some medium. So 5 was the old power when it was in air, but now when it is put inside some liquid, the new power is minus 1. Great. Now what are you going to put on the top and at the bottom? In the first scenario, it's in air, so it is just going to be mu of the lens, which is nothing but 1.5. 1.5, it was in air. Second time, the same lens was in some liquid, so mu L minus 1. That's the second time. Is that clear? Everyone? Be careful not to leave this 100 in centimeters. You have to convert in meters, because diopters is a SI unit. You have to convert everything into meters, else you will get a wrong answer. Now you can do the math over here. So 1.5 minus 1 is basically 0.5, and 1.5 by mu L, that's going to be 3 by 2, and you have 3 by 2, mu L is below, mu L is below minus 1, okay, and there you go. So this is basically minus 5. So what is the next few steps? Check this out. Now what I can do is I can just take these people on the top, bring 5 below, bring minus 5 below. So it will just become 3 by 2 mu L minus 1 is equal to 0.5 as it is. This minus 5, I bring it over here. So this will become minus 1 by 10. And this is 3 by 2 mu L. Bring this minus 1 over there, it will become plus 1. So 1 minus 1 by 10 will be nothing but 10 is common. It will be nothing but 9 by 10. Correct, guys? Just check this out. Just put it on the top in the same line. So this was 3 by 2 mu L. I've just brought that 1 over there. So 1 minus 1 by 10 is 9 by 10. So now this is 3 by 2 mu L. You can see 3 goes with 9 3 times, 2 goes with 10 5 times. So mu L will be 5 and 3 comes below, so 5 by 3. Just check this out. Just check this out. Yep, it is 5 by 3. Very good, Gosder. Stuti, continue watching the live part. Whatever part you have missed, you can watch the replay later on. Live sessions are very important. You get the feel, and immediately, as soon as the class ends, just watch the remaining part. So that way you don't have to wait for the time for me to end the class. Okay, don't think that, oh my god, I missed the class. Nothing like that. It's problem solving. Cool, guys. Very, very beautiful question. These kind of questions are very common. Sometimes they give you the refractive index of the medium and they ask you what is the new power. Sometimes they give you refractive index and the power, they ask you what is the refractive index of the lens. So all sorts of variations can happen. Next question. A student measures the focal length using object pin distance from the lens, measuring the distance V, okay. The graph between U and V. Basically, he plots UV graph. For a convex lens. Come on guys, 1 by V minus 1 by U is equal to 1 by F. So how will this graph look like? That's the question, guys. Come on, think about it. It's very simple. How you're going to solve it? Think carefully. There are some basic things when object distance is negative infinity, when object distance is negative infinity, then the image will be formed at the focal length, right? The image will be formed at the focal length, correct guys? And as the object comes closer and closer to the focal length, as the object comes closer and closer to the focal length, the image is formed, okay? Image is formed at plus infinity. This is how it works. So guys, it will have some asymptotes. It can't be straight lines for sure. It can't be straight lines for sure, because first of all, V is below, U is below. It is not V plus U. If it was addition on the top, then it could be straight line. It can't be a straight line. Straight line, the variables are on the numerator side, not in the denominator. The moment it becomes denominator, it will be a curved graph. Will it be this one or this one? Just check it out. When object is negative infinity, here it is not negative infinity, here it is there. When the object is negative infinity, the focal length is what the image distance is going to be. So you can see the image turns out to be the focal length. Image will be formed at the focal length. So hence that option C should be correct. It almost touches, you can see it touches the line over here. You can see that like this. It almost touches over here. So when object is made very, very far away, object is made to go very, very far away, the image almost goes close to this focal point. That makes sense, right? That's how it is, because the rays are parallel, they merge together at the focal length. Moving on to the next question. A convex lens of focal length 20, concave lens of focal length 5 are kept along the same axis with a distance between them. If a parallel beam of light falling on A leaves as a parallel beam, then the distance D in centimeters will be. Very interesting question. We have done this in practicals. Very good, Kamlesh. So practicals will also help you there. Oh, by the way, JEE is bound to give you questions from your practical book also. There might be 1 or 2 questions from your, not exactly practical book, but those experiments which are there, the formulas which are there in that experiment, or the procedure might be there in some of the problems, like the resonance tube experiment or finding the focal length or anything else like that. Okay, let's try this out. The convex lens is there of focal length 20. This is your convex lens. So focal length is 20. That means if the rays are parallel, then the rays meet somewhere over here. So this distance is 20 centimeters. Now there is a concave lens, so it diverges. So that means you put a concave lens in between, so that the rays which are merging, they again become parallel. The rays which are merging, they again become parallel. So this can happen if the rays fall on this concave lens and it becomes like this. The rays instead of meeting over there, they go just like this. They again become a parallel beam. This can only happen if the rays are aimed at the focal point of this lens. If this also happens to be the focal point of the other lens, then the rays which are aimed at the focus becomes parallel after refraction. That was one of the rules of drawing the ray diagram. Do you warriors remember it? Hello Rajita, welcome bacha. Everyone? Very good, Bhargav. Everyone remember this rule? So what is the focal length of the concave lens? The focal length of the concave lens is 5 centimeters as per the given question. This is 5 centimeters. This is the common focus point for both of them. So guys, what is the distance? What is the distance between both of them? 20 minus 5. 20 minus 5. So it is basically 15 centimeters. 15 centimeters. Where is that option? Option B. Perfecto. Perfecto. Excellent, guys. Very nice. Luxury, it's okay even if you are late. You can continue watching the class. This is just a problem solving class. Okay, now this is another beautiful question, guys. A lot of you are going to learn a lot of new things in this question. Okay, very fascinating one. Object is at a distance of 3f from a convex lens, okay, of focal length f. Slab is placed so that the image of the object will be formed nearest to the object if thickness of the slab is. Understood? Very good, Bhargav. Now, let me explain this concept to you first before going ahead. When you have a lens over here like this, imagine the object is over here, the image is formed over here. As you bring this object close, so if you bring it here, then there comes a point where the image is exactly of the same size, inverted, okay? As you bring the object closer, the image starts moving away. There comes a point where the object and the image are of the same size, but they're just inverted. And then finally, when you bring the object even further closer, then you see the image goes even further apart. You can see that as the object comes from far away, the image also moves, and there comes a point when both of them are of the same size but inverted, and then again the image moves far away towards infinity. This comes from infinity and this image goes to infinity. So there is some relative separation between them. There is some relative separation between them, and that relative separation is the least. It's the minimum when this is the least separation. This is the least separation when this object is basically at 2f and the image is formed at 2f. So when it is just equal in size but inverted, that's the smallest separation that you can get. That's it. So let's try to solve the question using this concept now, okay? Very crucial concept. It can be there in your notes. I hope you have downloaded that notes now. Okay, if you have not seen the Telegram channel, please join the Telegram channel and make sure you download the notes that I have given for your benefit. You don't have to, waste your time making notes. Most of the 90% of the notes will be already available to you. Okay, so as per this particular question, you have the lens, you have a glass slab. So what that glass slab will do, the object's image will be formed over here. Now this image becomes the new object. This is basically your apparent shift which has happened because of the slab over here. And if this new object, which is the image after the shift, just happens to be at 2f, then this separation will be the least. The final image which is formed, final image is the closest to that particular object, okay, is particular to that particular object. So what you're going to do is, this object, the original object was given to be at 3f. Original object was given to be at 3f. If you want to shift it to a point so that it comes to 2f, obviously the apparent shift has to be f. This is 3f, this is 2f. The shift has to be nothing but f. Correct? So use the shift formula. The shift formula is thickness into 1 minus 1 by mu. The shift is f. Thickness, I don't know, 1 minus 1 by mu as it is. Or if you want, you can take LCM. You can take LCM, guys. So it will become mu minus 1 divided by mu. Question was to find thickness. So it will become f into mu divided by mu minus 1. That's the answer, guys. Option number D, of course. So the object was at 3f. You want its image to be formed at 2f, so there is least separation. So you have to shift it by f. Use the shift formula. Just rearrange. Very simple. This concept was very crucial, guys. I loved this concept. Good evening, Shivani. Yes, first 2f, infinite. Second, yep. Now, two lenses of power, negative 15D and plus 5 diopters are in contact with each other. So lenses in contact, what happens? Their powers get added. The focal length of their combination. The focal length of their combination. So one is negative power, one is positive power. That means you have a concave lens as well as a convex lens. So the effective power will be P1 plus P2. That's the standard formula. So minus 15 plus 5 will give you minus 10. That's effective power. Now when you convert this into one single lens, because it's negative power, so that means it's diverging, it's a concave lens. This effective power will be 1 by f. This will be minus 10. So f will be minus 1 by 10. This will be meters. So this is basically f is minus 0.1 meter. This is nothing but minus 10 centimeters. minus 10 centimeters, which is option C, guys. Yes, a lot of students make a mistake. They forget that this was in meters. They just write it as 0.1, or they make a mistake with the sign and they get plus 10 centimeters. That is also wrong. Hari, I'll be doing PYQs of modern physics also. After ray optics, you know what is the next recording that you're going to get tomorrow, guys? How many of you know this? Anger Queen, the Telegram link is there in the description box only as you're watching this video, right? As you're watching this video, it's just there in the description box. And go ahead, guys, smash the like button also. If you guys have not yet done that, you should do that urgently. This is the link of the Telegram channel. So tomorrow, no, it's not wave optics. Tomorrow onwards, it's going to be modern physics. So atomic structure, then photoelectric effect, wave particle duality, nucleus, semiconductors. Just imagine doing these topics in 20 minutes, 30 minutes, how beneficial it is. And the best part about these lectures is because they're so crisp, short, there is no bakwas, there is no random things in it. You can just put on headphones and just listen to those lectures also again and again. And you can just keep on visualizing. That's the best part about these lectures, guys. So join the Telegram channel so that you get the updates of whenever I'm going to make the recording. And then I will conduct, once these things are done, the PYQs and problem solving for entire modern physics together. One big session will be there. Okay, moving on to the next one. Ray of light falls on the prism ABC. AB is equal to BC. The question is, what is the refractive index of the prism material? What should it be greater than? That's the question. What should it be greater than for this to happen? I think you can clearly see over here what is happening. The incident light, this falling inside the denser medium, it's getting totally internally reflected. This is your normal. And here also it is getting totally internally reflected, and it is coming at 90 degrees. There is no deviation here because it's just falling normally, so it will just go out normally. So if this has to happen, this total internal reflection has to happen, that means this must be the critical angle. Now how do I get that? Since AB is equal to BC, obviously this is 45 degrees and so is this 45 degrees. Isosceles right angle triangle. Isosceles right angle triangle. If that is 45 degrees, obviously guys, think about it, even this is 45 because this is 90 and even this is 45 degrees. So this is the critical angle, and we all know sine of critical angle is 1 by mu. So sine of 45 is 1 by mu. Sine 45 is 1 by root 2 is 1 by mu. So mu is basically root 2. That should be the answer. Option B. Yep, very good. So if you have a refractive index higher than root 2, 100% the ray will get internally reflected. Question was, what is the least value? So you will do it for the critical case when the angle of incidence is the critical angle. This is the standard formula. Yes, option B. Is my recorded lecture enough for revision? Yes. Preparation from zero? No. If you are obviously, Bhargav, think about it, na bacha, you are seeing a lecture for the first time, somebody teaches you in 35 minutes, then somebody will make all the lectures, within 3 hours the entire physics will be done, na? So you cannot do that. So if you are learning a chapter for the first time, please don't watch it. But yeah, if you have read it, if you have listened to the lecture, you have solved basic questions here and there, and now you want to revise through the chapter or you want to go through the theory quickly, what is there in the chapter you want to know, then go through those classes. Okay, moving on now to the next one. This is a beautiful question. In an experiment to determine the refractive index of the glass, okay, suffers deviation of 40 degrees, then emerges at an angle of 79 degrees. In that case, which of the following is the closest possible maximum value of the refractive index? Is the PYQs enough for JEE? Yes, definitely, bacha, it is enough for the first attempt if you do not have time, else it's going to be a problem. Okay, else it's going to be a problem. Now, this question, what you can do is just solve it graphically only, that will be better. This is deviation, this is angle of incidence, okay, and all of that. And what you can do is you can draw an approximate curve, something like this. Draw an approximate curve of deviation versus angle of incidence, something like this. It's given that the ray incident at 35 degrees suffers a deviation of 40 degrees. So let me start marking those angles. So if the angle of incidence is 35 degrees, the deviation is basically 40 degrees, and that it emerges at an angle of 79 degrees. Okay, it emerges at an angle of 79 degrees. So that means if the light is made to fall, at 79 degrees, still you will get the same deviation by reversibility principle. So the second angle that you get over here, that is basically 79 degrees. That's what it is. I hope this is clear, guys. Everyone with me on this? Clear? Understood? Very nice. Now the next part, in that case, which of the following is the closest and the maximum possible value of the refractive index? And also what is mentioned in the question is the deviation angle, which is 40 degrees. Now you just have to use two equations. I will not solve the problem completely. I'll just give an idea for solving the question. Okay, so here is your prism. This is how it is going to go. This is one normal, this is another normal. So this is 35 degrees. This is 79 degrees. This is R1. This is R2. Okay, and this is angle of prism. So as per the equations, delta is equal to I1 plus I2 minus A. So deviation is 40. I1 is 35 plus I2 is 79 minus A. Okay, from this you can find the value of A, guys. From this you can find the value of A. Atharsh, how did I draw the value of graph? This is an experimental graph, standard graph this is. Remember, there is minimum deviation. Remember, there is minimum deviation when angle of incidence is equal to angle of emergence and the ray is parallel to the base. So minimum deviation happens over here. So that graph leads us to the minimum deviation formula. Okay, I'll be covering high weightage syllabus first. All right, very good, guys. So what is angle of prism? So 35, 79. Just check this out. Take over here minus 5. Yes, 74. Just check this out. Is it 74 degrees? Yes, perfect. Then what you're going to do? Is nothing but use Snell's law over here. So sine of 35 by sine of R1 is equal to mu, which is also sine of angle of incidence over here 79 degrees upon sine of R2. But the best part is A also is R1 plus R2. So R2 is A minus R1. So it is 74 minus R1. So you can use that over here. You can just write it as sine of 79 divided by sine of 74 minus R1. Now the values are not that great, so you might have to use calculators for solving this, but if it comes in J, you will get it with good values and you will be able to solve such an equation. From this particular equation, you will be able to estimate, if these values are good, you will be able to estimate which is the correct value of mu. But otherwise, you will have to use calculators and then only to solve it. Okay, right now I just use this question just to explain you the concept behind it. Otherwise, you will be able to solve it with good values. Is that okay, bachalo? Option is A, which is 1.6. You can solve it after some time. A ray of light falls normally on a refracting surface of a prism of refractive index 1.5. If the ray of light just fails to emerge from the prism, then the angle of the prism is interesting. Definitely, Nagasai, you can definitely. Let's draw this diagram first. I have the prism over here. The ray of light falls normally on the refracting face of the prism. Normally, okay, and the angle of prism is not given, okay. If it falls normally, that means it goes like this, and it just fails to emerge, that means there is total internal reflection. So if I draw a normal here, this is basically your critical angle. This is normal incidence. Correct, guys? Perfect. So this is critical angle. So naturally, this angle over here, because this is 90 degrees, this angle, shouldn't it be 90 minus the critical angle? Shouldn't this angle be 90 minus the critical angle? Do you see one more right angle triangle here? So in that right angle triangle, this is 90, this is 90 minus I. How much will this angle be? This will be also I. Because if this is I, this is 90 minus I, because this is a right angle triangle. Perfect. Now what is the question? The question is, the ray just fails to emerge out of it. The question is, what is the angle of the prism? This itself is the angle of the prism. So how do I find I? Sine I is 1 by mu, which is 1 by 3 by 2, which is basically 2 by 3. So IC will be sine inverse of 2 by 3. So A, which is also equal to IC, will be sine inverse of 2 by 3. That's it. That's the answer. Where is it? Option A. Perfect. I hope, Likita, you are having a great time, bacha. Answer A. Perfect. So it's complete geometry. Critical angle, 90 minus critical angle, again critical angle. That's exactly the angle of the prism. Moving on to the next one. A light ray is incident at 60 degrees on a prism of angle 45 degrees. When the light ray falls on the other surface at 90 degrees, the refractive index of the material of the prism is mu and the angle of deviation delta are given by. Interesting question, guys. Again, start with the diagram. Without diagram, you cannot get anything. You have this prism, okay? The angle of the prism is given to be 45 degrees. Light is incident at 60 degrees. Light is incident at 60 degrees. So clearly this is 60 degrees. After refraction, what happens is the light falls on the other surface at 90 degrees. If it falls on the other surface at 90 degrees, it's just going to emerge out of it like this. That's what is going to happen. Correct, my warriors? This is exactly what is going to happen. This is 90 degrees. This is also 90 degrees. Perfect. The question is, if the refractive index of the material is mu, the angle of deviation is given by. Okay, perfect. So let's try to understand what is happening. This is I1. Here, I2 is not 90. That's a common mistake. I2 is actually 0. I2 is 0. If it falls normally, with the normal it makes 0. Angles are always measured with normal. It's mentioned here, it falls at 90 on the surface. With the surface it makes 90. With the normal it makes 0. Now we all know delta is I1 plus I2 minus A. Somebody was asking how to solve problems of prism which has angles. This is how we solve it. It's complete geometry. I1, oh, I do not know that. But can I find it out? Maybe yes. Maybe yes. How? Let's see. Observe now carefully. If this is 45, this is 90, how much will this angle be, guys? Obviously, this will be also 45 degrees. And this is 90 degrees. So how much will this angle be? This will be also 45 degrees. So I1 will be 45. I1 will be 45. So substitute I1 as 45. I2 is 0. Angle of the prism is nothing but 45 degrees. I think something went wrong over here. Let me just check. Oh, I'm so sorry, guys. I1 is not 45. I'm so sorry. I1 is not 45. So sorry, guys. Let me just do this again. This was R1, R2. My bad. Okay, just one second. I'm just going to do this again. Just one sec. Okay, so over here, this 60 degrees is basically I1. This internal angle is R1. This internal other angle R2 is 0. And this exterior angle is I2. Correct? The exterior angle is I2. This is exterior angle I1. R1 and R2 are the internal angles. I hope this is clear. Perfect? Okay. Now we can see clearly over here that this is 90. This is 90. So naturally, this is also 90. In this small little triangle, you can see if this is 90, this is 45. Naturally, this is also going to be 45 degrees. This is also going to be 45 degrees. Perfect. Great. If this is 45, then this also is going to be 45 degrees. This is also going to be 45 degrees. Now you can use Snell's law over here. This is incidence, this is refraction angle. So sine of I1 by sine of R1 is equal to mu. So it is sine of 60 by sine of 45 is equal to mu. So mu will be sine 60 is root 3 by 2. Sine 45 is 1 by root 2. Root 2 cancels. It will become root of 3 by 2. Root 2 cancels. Root 3 by root 2 is root of 3 by 2. So now I got the value of mu I got the value of mu. I can see either it will be A or D. Last point is finding the deviation, which is I1 plus I2 minus A. I1 is going to be 60 degrees. I2 is going to be 0. You can see that I2 is going to be 0. Is the angle weighed with the normal, not with the surface. So minus angle of prism, it is 45. So this is going to be 15 degrees. So that is the other answer which we want. Where do we have it? Yes, option D. Correcto. Correcto. Very good. Tech vlogs. Very good. Arvind. Yes. Amazing. If I'm not able to do the questions of this session, is it? If I'm able to do the questions of this session, it is enough, right? Yes, tech vlogs. That gives you good confidence. Then you can move on to the other chapters. That's good. If you're getting 70 marks in full syllabus mock test, is it reasonable for me to aim above 180 in Jan attempt? 70 marks to 180? No, bacha. It is double. That's not reasonable. Definitely not edits. Okay, moving on to the next one. Microscope has an objective focal length of 1.5, eyepiece focal length of 2.5. The distance between objective and eyepiece is 25. What is the approximate value of magnification produced for the relaxed eye? Okay, there was a direct formula which I had given you guys. There was a direct formula which I had given you for finding the magnifying power of your, microscope, and that too for relaxed eye. When the eyes is relaxed, then the formula is L into D into F naught Fe. L is the length of the tube or distance between the objective and the eyepiece lens. The distance between objective and the eyepiece lens is 25 centimeters. Least distance of distinct vision is capital D. For an average human, it is 25 centimeters. Focal length of objective and eyepiece 1.5 and 2.5. So one is 1.5, another one is 2.5. You can see 2.5 goes with 25 10 times. Okay, so you can write this as 25 by 15. You can shift that decimal because it will go up and it will become 100. 15 and 25. 15 goes with 5 3 times. 25 goes with 5 times. So it is just going to be 500 by 3, which is going to come very close to, out of all the options, it's going to come very close to, approximate to 160. Actually, it will be something like 1.66, but okay, 160 is a good approximation. Is that clear, guys? Everyone with me on this? So this is the formula which I have given to you in the in the mind maps and the formula session. 35 minutes complete re-optics. This was the recording. Next, direct application of formulas, guys, is generally there in the optical instruments questions. If you know the formulas, you know the working, you will not face much difficulty. The magnifying power of a telescope is 8. The distance between them is 54. The focal length of both the lenses will be. Okay, let's try this out. First of all, the length is given and power is given. Magnifying power is F0 by Fe and length is F0 plus Fe. So from this, 8 is equal to F0 by Fe. That means F0 is 8 times of Fe. And from this, what is the length? It's 54. 54 is F0 plus Fe. That means 54 is F0, which is 8 times Fe plus Fe. So 9 times Fe is equal to 54. So Fe is nothing but 6 nothing but centimeters. If this is 6 centimeters, you can easily find the value of Fo. So Fo will be nothing but length minus Fe. So it will be 54 minus 6, which is 48 centimeters. So that is another focal length which you got. So where is it? 48 and 6 centimeters. Yes, option A. Perfect, Bhargav. Excellent. Very good. Sheikh, these sessions will be useful for your EMSAT bacha. Earlier, we were predicting that okay, JEE will happen in April. But now JEE exam is there just in few weeks. So will you prepare for JEE or will you prepare for EMSAT? Obviously, you will prepare for JEE, which also will prepare you for EMSAT. So use these sessions to learn the theory. Don't ask, sir, conduct re-optics session theory for EMSAT. What will I teach separately? Think and logically tell me. Yeah, Problem solving session, PYQ session for ray optics for EMSAT, that is one session which I'll conduct. Don't worry about that. But let's at least revise all the things, and January is our primary focus now. After January is over, even if you're a dropper of JEE or EMSAT or something else, we will focus on the PYQ problem solving, etc. after January. I hope that makes sense. Okay. How do you decide between option A and B? For the eyepiece and the objective. Eyepiece is first, objective is next. So eyepiece is 6. 6 is first. Look at what comes first, eye and objective. The order is important. Order is important. So eye is basically 6 centimeters, which is basically this option. This objective is this one, which is 48 centimeters. Is that clear, bacha? All right. Moving on to another question. All right. I hope Sheikh bacha, it's clear bacha. Okay. Just don't keep spamming about it. Okay. Sir, I'm 11th standard. From today, I started studying ray optics after this session. Very good, Sanjay. You can watch my Pathfinder series. You can definitely get a lot of knowledge from those sessions. So, simple telescope consisting of an objective of focal length 30 and single eye lens of focal length 6. Eye observes final image in the relaxed condition. If the angle subtended of an objective on the objective is 1.5, then the image will subtend how much angle? Okay, I'll tell you what this is about. The magnifying power is the angle subtended by the image upon the angle subtended by the object. You can see the object subtending certain angle. If the image subtends larger angle, it has been magnified. That is the magnifying power. Also, the magnifying power of a telescope for a telescope is f0 and f is ratio. That's it. So just use that and you will get the answer. f0 by fe. We can see over here it's 30 and 6. So 30 by 6 is angle subtended by the image upon angle subtended by the object is 1.5 degrees. So angle subtended by the image will be 30 by 6 is 5. 5 into 1.5 degrees, which is 7.5 degrees. That's it. That's the answer, guys. That's the answer. Perfecto. Simple questions are there. From telescope, microscope, all these optical instruments, you cannot afford to leave these questions and lose marks. I am expecting 2 questions in most of the JEE paper. They will give you 2 questions. That's 8 marks. That's the weightage, roughly on an average, if you see from ray optics. Okay. So I hope this is clear. Great. Great. Will all important chapters be covered in fast track? Likita Kure? Yes. I have already done before this 1 chapter. Okay. And now this is the 2nd chapter. Now I'll be doing more chapters in the days to come. I'm very good, Aisha. How can I reduce my sleeping hours? I'm sleeping for like 7 hours. Just ask somebody to throw water. Number 1, drink coffee or tea in the morning or whenever you wake up so that you can push yourself. Set multiple alarms and also drink a lot of water so that you feel like urinating in the middle of the night or just early morning. So just drink that much sufficient water which will wake you up, because that's how body works. It will automatically, physically make you urinate and automatically you will wake up. And once you wake up, that's it. Everything is lost. The sleep is lost. Okay. So there are some homework questions for all of you. This is the first homework question. Try to solve it. And this is your 2nd homework question. Please try to solve it. Put the answers in the comment section. And thank you for liking and, subscribing as well. Bhargav, what I did in the last question, right, is I just took the, where is it? Angle subtended by the image and angle subtended by the object. That ratio gives you, magnifying power. That's how it is defined actually. Instead of height, it is angle. And this is the formula for telescope, f0 by fe. f0, 30. fe, focal length of the eyepiece, 6. 30 by 6 is 5. 30 by 6 is 5. Take 1.5 on the top. So 5 into 1.5 will be 7.5. That's the angle subtended by the image. Then the angle subtended by the image will be how much? That's the question. Yeah. Thank you, Rakesh, so much. I'm so glad that you guys enjoyed it. I'll see you guys tomorrow. But it will be a recorded session. It will be a premiered session, remember. But you have to watch it live. because you will complete that chapter. So I'm going to give you 2-3 recordings in the days to come, and then we'll have a problem solving session. Just make a promise that you're going to attend these classes. Do not forget to leave a lovely comment after the session is over, and keep motivated, stay motivated, and attend these classes meant for you in the fast track series. Problem solving sessions are separate, theory sessions are separate. Keep this in mind. Okay, bye bye guys, this was Captain Shreyas signing off. Hasta la vista. Thank you for liking and subscribing.